Welcome to qnawire.
All right. So first up, we've got caffeine. We've got to determine how many chemically non-equivalent hydrogens there are in this structure. So we've got to identify where there are hydrogens. Well, there's some that are more obvious than others, right? Here's a methyl group here, and here's a methyl group here, right? And I forgot to draw it, but there's also a methyl group here. And so we first might want to ask ourselves, are these all chemically equivalent? Or are they chemically non-equivalent? Well, for them to be chemically equivalent, there'd have to be some sort of symmetry that would make them, interchangeable if we were to rotate the molecule. Like if we rotated around that carbonyl, we'd swap this nitrogen for that nitrogen. But we can very, very, very quickly verify that that wouldn't be the case because this nitrogen neighbors a carbonyl, whereas this nitrogen does not neighbor a carbonyl. So they can't be chemically equivalent. So the methyl groups on them can't be chemically equivalent either. And in fact, there's not nearly enough. There's no chemically non-equivalent, just positions in general on this molecule. So any hydrogens we find are going to be chemically equivalent. But the tricky thing here is that there is one hydrogen we have not drawn. Right? This is a carbon. It's got 1, 2, 3 bonds shown. And because we put implicit hydrogens wherever carbons don't have 4 bonds, that means there's a bond hydrogen unshown in that location. And it is chemically non-equivalent. So we have a total of 4 in our caffeine structure. I would also point out that these methyl groups, we don't say that there's 3 because all 3 hydrogens are bound to a single carbon. These are all chemically equivalent in the sense that this only counts for 1, and this methyl group counts for 2, and this methyl group counts for 3, and this single hydrogen counts as the 4th, right? So all the hydrogens on a methyl group will always be chemically equivalent. Okay, let's move on to the second structure. We've got hopefully this looks right. I'm drawing it a little differently with the bond line drawing, but I'm drawing all the hydrogens explicitly. Great. And let's find our chemically equivalent hydrogens. So once again, while this methyl group has 3 hydrogens, since they're all attached to the same carbon, that counts as 1 set of chemically equivalent hydrogens. These hydrogens are also attached to the same carbon, so they all count as 1 set of chemically equivalent hydrogens. This hydrogen here, it's all on its lonesome, but it still counts as being a single chemically equivalent hydrogen, just as all 3 of the hydrogens on this nitrogen count as being chemically equivalent as well, for a total of 4 chemically non-equivalent hydrogens. So the answer is 4 in both cases.